In this video we look at Z scores. So we use Z scores to calculate the area under a normal curve. So on the right here we have a normal curve. It shows the mass of potatoes. So if we assume that the mass of potatoes are normally distributed and they have a mean of 150 grams with a standard deviation, we should maybe write this down. So a mean of 150 and a standard deviation of 20 grams, then this is what the normal distribution might look like. And we've looked at how we can find area in certain parts of this graph. For example, we know that 68% of the data lies within 2 standard deviations, so 68% of the data lies here. Similarly, we could say that if we just want to look at the section to the left of the mean, in here, we know that 68% of the data lies within 1 standard deviation, so here and here. Well, half of that value then must be 34, so we must know that 34% lies here. So that's why the normal distribution is useful. The trouble is that if we wanted to know what percentage of the data lies, let's say between 120 and 130 grams, we would have a little bit more work to do. And we're going to look at how we do that work right now. It's not as simple, but it's not too difficult either. So in order to do this, we need to understand this concept of a Z-score. So a Z-score is just a measure of the number of standard deviations a given point is above or below the mean. So how many standard deviations is a point above or below a mean? Another way to think about this is we want to take this graph and turn it into this one. This is called the standard normal distribution. I've written that down over here. A standard normal distribution is a distribution that has a mean of 0 and a standard deviation of 1. And we want to be able to change the values from this table into this table. And we do that with Z-scores. So what we want to do is to figure out, well, how many standard deviations, well, this one's a nice easy one, how many standard deviations is 170 away from the mean? Well, it's exactly 1 standard deviation away. Again, the values that we talked about, that 68% and 95% and so on, those values are easy to find, but what about the values that don't lie on even number of standard deviations? Luckily, somebody's gone through the hard work here. We're talking about area under a curve. We can do that with calculus, but somebody else has actually gone through and for this standard normal distribution created a table, we'll look at that table shortly, of the areas under the curve for certain values. So first let's look at Z-scores though. So here's how we calculate Z-scores. So the Z here just represents the Z-score. X is an individual data point. So in the example that we did over here, that was the 170, so that's a data point. Mu is the mean, and sigma is the standard deviation. So with the standard deviation and the mean, we can find a Z-score, and what the Z-score will indicate to us where on this curve are we talking about here. So what is the value here for Z down here? Because as we'll see shortly, if we know that, then we can look up the area under the curve here and use that information to find different probabilities. Now there are 2 formulas for Z-scores. There's one for a population and one for a sample, and you can see that those 2 formulas are very similar. The only difference is that the sample Z-score uses the sample mean, so X bar, just a reminder, that's the sample mean, and S is the sample standard deviation. So S down here is the sample standard deviation. Alright, so let's look at how we can use this information. So we talked a little bit about how we can change the normal distribution to what we call a standard normal distribution using Z-scores. Let's get into some details here. Here's that table that I was mentioning. Again, somebody else has gone through the trouble of creating these values. You'll see here, I'll just mention this a couple of times, but you can see here at the very top of the, the table, we can see this sort of shaded section in here. That's showing you that the area in the table is the area to the left of the value. And we call that the percentile. So this table gives the percentile of a given value. And a percentile, if you're not sure what that is just the percentage of the data that is below a given point. And that's why we're looking only to the left, because it's a percentile, and the percentile gives values to the left. So let's look at how we can use this table using our potato example. So we talk about the potatoes. They have a mean of 150 grams and a standard deviation of 20. I think I left that out, so I'll just add that in here. Standard deviation of 20. And the question is, find the probability of the following. So let's find the probability that a potato has a mass less than 130 grams. We can draw a little picture that might help us, give us some indication of what we're doing. We know it's a normal distribution. We know that the mean is 150. And we know that the standard deviation is 20. So this standard deviation is 20. We could probably write this as mu, sorry, that's a bad look at mu. Mu equals, so that's the mean is 150, and the standard deviation sigma is equal to 20. So we want to find the probability that our random variable x, so x in this case being the mass of a potato, we should probably write that somewhere. I'll stick it up here because I have a little bit of room. X represents the mass of potatoes. So what's the probability that x is less than 130? So if we were looking for 130 again on our picture, that's somewhere over here. 130 is over here. We want this area right here, the probability that x is less than. So less than is going to be down here. Again, the table on the right doesn't give us information for this curve that has a mean of 130 and a standard deviation of 20. It gives us, the information for a curve that has a mean of 0 and a standard deviation of 1. So what we need to do is we need to convert this 130 to a z-score. So we use that z-score formula. Z is equal to x minus the mean divided by the standard deviation. So in this case, the x value is 130, our value here that we're trying to find. We subtract the mean from that, and we divide by the standard deviation, which is 20. Sorry, we know what the mean is. We can just write that in. I'm not sure why I wrote mu in there. We know that the mean is 150. So we can plug in 150 here. And if we do the arithmetic here, 130 minus 150 is negative 20 divided by 20, and I'll just stick that over here, equals negative 1. So we found that this z-score here is negative 1. So the probability that x is less than 130 is the same as the probability that z is less than negative 1. Now here's where this table comes in. So we want to find the probability that z is less than negative 1. Here are the z values here. You can see in this table, this is only half the table. I'll show you the other half shortly, but just to keep it all on one page and the work here, we can see here that the z value goes from negative 3.4 all the way up to 0 in this column here, and then, in this row. And the rows here, the columns here indicate the second decimal place, or the hundredths spot. So for example, if I looked at this particular value, let's choose one right here, this particular value right here, this has a z-score of negative 2.94 because the second decimal place here is a 4. So negative 2.94 in our table would be right here. Now we're looking for negative 1. We want the probability that z is less than negative 1. So negative 1 we said was over here. That's somewhere in here. On our table, we're going to find z, and I almost said scroll down, but look down until we find negative 1. Oh, here it is. And we want negative 1.00, which is just happens to be this value right here. So the probability that Z is less than -1 is equal to 0.1587. That means there's a 16% chance, almost 16% chance that the mass of a potato chosen at random is less than 130 grams. So that's how we can do a fairly straightforward example. We could have done this, by the way, just using what we knew. I chose the 130 grams because I know it was 1 standard deviation away, and we could have used the information about the number of standard deviations and so on. Let's look at a slightly different example, slightly more complicated, I think, example. And this example is to find the mass greater than 160. So again, I'm going to draw a little sketch of the distribution just to give me a sense of what it is that we're looking for. So again, the mean is 150, and we want to know the probability. In fact, I'm going to change this because I don't have the table here for 160. I'm going to change this to 135, just because the table's in front of us. We'll use that table. I'll show you the rest of the table and just let you know how to use it. So we want to find the probability that the mass is greater than 135. So 135 is over here somewhere. We don't know exactly where, but this is just a rough sketch. And we want the probability that x is greater than 135. We want all of this. So remember that the area under the curve is equal to 1. The table will give us this area right here. So if we want to find the area shaded in red, we need to do 1 minus the area shaded in green here. So let's kind of work through that process. So the probability that x is greater than 135 is just equal to 1 minus the probability that x is less than 135. So again, we want the table will give us this chunk right here. We know that the total area under the curve, so the total area under this curve here, is equal to 1. If we take 1 and subtract the green area, we subtract this green area, we'll get the red area, which is what we're after. And that's why I find a picture is helpful here, because it helps you understand which part of the curve are you looking for. So that's the part that we should get. So we need to find the probability that x is less than 135. In order to do that, we're going to change that x value into a z-score. And I'll try to squeeze this in down here. So z is equal to 135 minus 150, that's the mean, divided by the standard deviation. And just to save a little bit of room, I'll let you kind of just double check, but I think if I have done my calculation correctly, I believe that gives us negative 0.75. So this probability is equal to 1 minus the probability that z is less than 0.75. So all we did is we changed that 135 into a z-score, and now that we have the z-score, we can go to the table and look up 0.75. Sorry, this is a negative. I left out the negative sign here. So that's a negative 0.75. So we're going to get 1 minus whatever the z-score is for 0.75, negative 0.75. So here's negative 0.7 right in here, and we need negative 0.75, which will be this column right here, and we can look that up and say, here's the value right here, 0.2266. And so 1 minus 0.2266 gives us 0.77. So that means that there's a 77% chance that the mass of a potato chosen at random is greater than that 135 that we started with. Alright, and one final example here to make sure that we can put this all together. This one's asking something a little different. Again, I'm going to sketch a little picture so we can have a sense of what's going on here. The question's asking, what's the probability that a mass is between 120 grams and 135 grams? So let me fix that up because that's very hard to read. I'm going to make that a little bit bigger so we can see it a little bit better. So we take our normal distribution, and we want to find the probability that x is between 120 and 135. Remember, we know the mean is 150, which is somewhere over here. But what we really want to find here is this little chunk in here. So again, the table doesn't give us that. The table only gives us values to the left of certain values. So we want the probability that x is between 120. So 120 is less than x, which is less than 135. And in order to do that, what we can do is we can take the probability that x is less than 135. So that's this region right here. X is less than 135 is all of this. And then if we subtract the region where x is less than 120, that'll give us what's left in red here. So that's what we're going to do. So this is equal to the probability that x is less than 135 minus the probability that x is less than 120. So again, we would go through the process of converting these to z-scores. We've already done the 135 as a z-score. We did it up in the example up here. So this is the probability that z is less than negative 0.75. And we want to subtract from that, and I'll just do the calculation over here for 120. Z is equal to 120 minus 150 over 20. And so if we go ahead and do that, we should see here that the z-score is, let's see, this works out to negative 3 over 2, I believe. Negative 30 over 20, so we get negative 1.5. So the probability that z is less than negative 1.5. So again, we can go to the table and look these values up. We already looked up the one value, but just as a reminder here, probability that z is less than negative 0.75, negative 0.75 happens here, so this is 0.2266, and we subtract the probability that z is less than negative 1.5. So here's the negative 1. We're looking for negative 1.5, which is this column here, which looks like 0.14. Let me just double check that point. Oh no, that's all right. Negative 1.5. Sorry, just wanted to look for negative 1.5. I'm actually looking at negative 1.05. We want negative 1.5, which is this value right here. So negative 1.50 is 0.668. And if we, sorry, that's a 0.0668. And if we plug that into our calculators, we should get an answer of 0.1598. So again, the probability that a potato chosen at random is between 125 and 135 grams is about 16% here. So that's how we can use this table and this idea of a z-score to find probabilities. So the idea is that we change our normal distribution to a standard normal distribution, and then we can look up values in the table. I did promise I'd show you the entire table. Here's the entire table. So the first table only had negative values for z. These ones right here. The second half of that table has the positive values as well. So the examples that we did only had z scores that were negative, but it's just as likely that you're going to have z scores that are positive. The process is exactly the same. One other quick thing that I want to talk about is you may be asked to go the other way from the table. So you may be asked, for instance, to find what is the z-score for the 95th percentile, say. So you kind of go backwards in the table. If we're looking for the 95th percentile, we're going to find 0.95 in this table. And maybe that wasn't a good one to look at, but because I see 0.9495 is here and 0.9505 is here, both of those are equidistant from 95%. So we could actually technically choose either one of those. So I'm going to choose this one just because there's no real reason. And go across and see what the Z-score is. So I come across this way and see that the Z-score, if I point at the right one here, is 1.6, and then I have to read off this value up here, so 1.64. And then we can use that Z-score actually to find, a mass of a potato, say, using the Z-score formula that we talked about earlier. So Z equals x minus the mean over the standard deviation. So if we know that the Z-score is 1.64, and we're trying to find out what the mass of the potato is, we know that this is 150, and we know the standard deviation is 20. So you might be asked, what size potato gives you the 95th percentile? And that's how you would do that. And then you would solve this equation for x, multiply both sides by 20, and then add 150 from there. So that's an introduction to Z-scores. Hopefully that was useful, and hopefully that's cleared up a few things.